All right, starting our semester final review, we're going to do 1 through 14 today on your review worksheet. So, starting off with number 1, biggest thing for this whole final is going to be reading the directions. Okay? So, the perpendicular bisector of FN is AB. So here, AB is a perpendicular bisector. What does that mean? What does perpendicular bisector mean? Splits the side in half. There's one more thing with that. So we figured out bisector. That splits the side in half. What's perpendicular? 90 degrees. Yep. So it wants us to find the length of AN. Well, in order to find the length of AN, what do we need to find first? We need to find what R is first. How do I find the value of R? Why can we set these two equations equal to each other? How do we know they're equal? How do we know those two lines are equal to each other? They meet at the same point. So we can assume these two lines are equal to each other because they meet at the same point. Okay? So you guys said we're going to set them equal to each other since we know they're the same. So 5R minus 3 equals R plus 25. How do I solve from here? Add 3. So I have 5R equals R plus 28. Subtract R. So I have 4R equals 28. What do I get for the value of R? R equals 7. A lot of us yesterday circled this, but then we looked at the key and saw it was wrong. Okay? Make sure we are reading the directions. It wants us to find the value of AN. So how do I find the value of AN? Plug 7 in for R. So I have 7 plus 25, which equals 32. So C is the correct answer. Number 2. These boxes right here, that serves as your word bank. Okay, this is kind of a fill in the blank question. So AB is parallel to XY. Okay, so line AB is parallel to line XY. AB and XY are reflected over the x-axis to form AB prime and XY prime. What does this mean? The primes. What does that stand for? The new image, right? It wants us to complete the statement. AB prime is blank to XY prime. So the original AB is parallel to XY. What's AB prime compared to XY prime? It's still parallel. Okay, why does it not change? All that's happening to the shape is it's just getting flipped. Okay, nothing else is happening. It's not changing size. It's not moving it in any weird way. All it's doing is flipping it. So this original statement does not change. It's going to stay the same. Okay, what if I change this word parallel? What if I change it to congruent? It would stay congruent, right? No matter the reflection or what's happening, it's going to stay congruent. Same thing if I put the word perpendicular in here. Would they stay perpendicular to each other? Yes. Okay. All right, moving on to number 3. It says, given 2 points, what is the midpoint and what is the distance of points A and B? So I have our formulas up here. The midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. What's going to help us before we start plugging in numbers? Labeling. How do I label A? x1, y1, b, x2, y2. So now we just plug in those values. x1 is negative 4 plus 8 over 2. And then y1's negative 2 plus 6 over 2. So now we just evaluate. Numerator is negative 4 plus 8. 4 over 2. Negative 2 plus 6. 4 over 2. Last thing, divide. What's 4 divided by 2? 2 for both. You can either write your answers in there or you can just circle your answer like that. Either way. Okay. Biggest thing with these formulas is to watch out for negative signs. Typo. Distance is not written as an ordered pair. I did fix that on your test. Okay, so following the distance formula, we have d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, it's just plugging in values. Biggest thing is keeping the square root the whole time until you use it. X2 is 8 minus what? -4. What do those two negatives turn into? Positives. Plus y2 is 6 minus -2 squared. So these turn into positives as well. Like I said, biggest thing is being careful with those negatives. 8 plus 4, 12. 6 plus 2, 8. What's 12 squared? 144. 8 squared? 64. So 144 plus 64 is 208. If you type this in your calculator, do you get a nice answer? No, so what do? Leave it. Okay, a lot of you wrote it as decimals. I prefer you just leaving it in a radical form. Okay, in Algebra 2, you will learn how to simplify these, but we're not going to go that far in geometry. Okay, so all you got to do, if it doesn't come out evenly, just leave it. Okay, I'm going to ask you something. Is the square root of 208 a lot different than the value of 208? Okay, so do I have the right to count you wrong if you don't have the square root on it? Completely different answer. Okay, so with those formulas, they have an outline for you. You just have to make sure you plug it in correctly and solve. Jumping up to number 4. Okay, again, like I said, reading the problem and reading the directions is very important. Okay, to know what you're looking for and to know how to understand what's given to you. Okay, so number 4 says transversal T passes through parallel lines P and S. What is the value of A? Okay, so we know that P and S are parallel to each other, and we have this transversal. What are the two options for angles when you have parallel lines and a transversal?
60 or 180.
They can either add up to 180 or they can be the same, right? Two options are they're the same or they add up to 180. So looking at these two angles that are given to us, are they the same or are they going to add up to 180? They're going to add to 180 because one of them's acute, one of them's obtuse. So they can't be the same. So we know they have to add up to 180. So what's an equation I can write if I know these two angles add up to 180?
10a plus 2 plus 5a minus 2.
Yep, we're going to add the two angles together. So I have 10a plus 2 plus 5a minus 2 equals 180. What I did there is I took my two angles and I added them together to equal 180. So now we just solve combine like terms on the left side. What's 10a plus 5a? 15a. 2 minus 2? You agree these cancel? So we're left with equals 180. What's my last step here? Divide by 15. A equals 12. Is that my answer? How do I know I'm done? Right, because all it's asking for is the value of A. Okay, it's not asking for a specific angle measure. It's just asking for the value of A. Okay. All right, last one on page 1 is number 5. We're given a little roadmap. It says select all true statements about the figure below. So I'm just going to go through each question. So on A, it says Sumac Street, which is here, is parallel to Pine Street. True, yes or no?
Yes.
How do you know it's true? Okay, how many of you looked at the picture and saw that they didn't touch? Okay, what do we need to do to make sure they're the exact same?
Slope.
Right, we need to know that their slopes are the same. So in order to know that they are exactly parallel, we need to find the slope. How do I find the slope given a picture? Find 2 points, right? Because slope is in the form of rise over run. Okay, so to find rise over run, we need to find 2 perfect points. So for example, Sumac Street, here are 2 perfect points. Now just count the rise over run from those 2 points. So what's my rise? 2 over 1, which turns to 2. So my slope for Sumac Street is 2. So now I do the same thing for Pine Street. Okay, so I find 2 perfect points. For Pine Street, what's my slope? Up 2 over 1. So, are these in fact parallel? Yes. Okay. If I got a slope of 3 and a slope of 2, can I say, close enough, it's parallel? No. They have to be exactly the same. Okay. So, part B, we're going to do the same thing, but with Pond Street and Pine Street. So, here's Pond Street. Is that parallel to Pine Street? Why not?
Because if it keeps going down, I'm sorry.
Right. Do we even need to find the slopes of these two to know that? No. Okay. One of them straight up and down. The other is angled. Are they going to touch at some point when they're extended? Yes. So we know B is incorrect. Okay. Let me erase my picture for a second. Part C, C through E actually, is talking about 2 parallel lines in a transversal. Okay. So keep in mind, we said earlier that Pine Street and Sumac Street are parallel. Which one's the transversal? Everyone agree this is a transversal? Okay. So we're comparing angle 1 and angle 4. Are these 2 angles congruent? Are they the same? Yes. What's the relationship there? For 1 and 4. Alternate. Yep, those are alternate interior. You do not have to specify on the test. Okay, I'm just doing it now so I can help explain the reasoning. Letter D. We are comparing angle 1 to angle 2. Are those congruent to each other?
Yeah.
Yes. What's the relationship? Vertical angles. And then last one, angle 1 and angle 3. Are those the same? No. So we know E is wrong. So your correct answers on this one are A, C, and D. All right. I had to laugh yesterday. A lot of us got to number 6 and saw it, and they're like, nope, I don't know how to do it, and they skipped it. Or you came and asked me. Why do you think we did that? Because it's a word problem. Okay? I would not throw a word problem at you if you didn't know how to do it or you didn't understand it. Okay? With these word problems, you just have to read each part and just get the information they give you. Okay? So let's practice doing that. So it says the city plans a new road that will be parallel to Village Way and pass through the intersection of Gray Drive and Cannon Road. What is the equation of the road in slope-intercept form? What I recommend you do, look at the question. We want to know what it's asking so we know what we need to work for. Okay? It wants us to write an equation in slope-intercept form. What is that? Y equals mx plus b. So we know we need an equation that looks like that. Okay? So I'm going to go through and read the rest. It wants a road that is parallel to Village Way. Why did I underline that? Why does that help us? It'll give us the slope, right? Parallel, is that going to be the same slope or different slope? Parallel is going to be the same. So I'm going to find Village Way. Again, just like we did on page 1, slope is rise over run. Find 2 perfect points on Village Way. Here's Village Way. I'm going to pick this point and this point. What's my slope? 2 over 1, which is 2. Again, it's parallel, so do we keep it the same or change it? Keep it the same. Okay. The next information they gave us is through the intersection of Gray Drive and Cannon Road. Why did they give us that information?
Because it tells you where your points are going to be.
It gives us a coordinate, right? So here's Cannon Road. Here's Gray Drive. Where do they intersect at? 3, -4. So our point is 3, -4. Looking at the question here, is there any other information we need to get from it? Or is that all they gave us? That's it, right? So now we get to work with what we're given. So again, we're working with y equals mx plus b. Plug in what you know. These coordinates are always in the form of xy. So what's my y value? -4 equals my slope. Slope is 2 times x 3 plus b, right? We don't know what the b value is yet. That's the point of setting it up like this. Now we need to solve. What's 2 times 3? 6 plus b. From here, subtract 6. So I get b equals -10. A lot of times, this is where we get confused. Little brain farts happen here. We forget what we have to do next. All we have to do now is write our specific equation for what we're given. Okay? What are the two most important things when you're writing a slope-intercept form equation? The slope and the b. Okay? We have the slope and we have our b. So we just write our equation. Our equation is y equals slope 2x minus 10. That is our intercept form equation. So, number 7, it tells us that measure of angle 1 is x. Let me erase what I have. Okay. Measure of angle 1 is x. Why did I do that? Then it says select all the angles that have a measure of 180 minus x. What does that mean? What do we know about x and the other angle? What do they add up to? Add up to 180. Okay? So, measure of angle 1, we're going to go through. Do 1 and 3 add up to 180. What's the reasoning?
They're just like obtuse and acute. So
Right, they're obtuse and acute. Remember, when you're working with parallel lines and transversals, you have two options. They're either congruent or they add up to 180. Okay? 4. Are 1 and 4 add up to 180?
no,
Why not?
because they're obtuse. They're both obtuse.
Right, and they're vertical angles. We know vertical angles are the same. Okay? 1 and 5, do those add up to 180?
No.
Nope. 1 and 10. Yes, one's acute, one's obtuse. Last one, 1 and 11.
Wait, yeah.
Yes, because one's acute, one's obtuse. So your correct answers on that one are A, D, and E. Number 8, what is number 8 very similar to? Number 6, okay? What's different about number 8 compared to number 6 is that it gives us all the information already. We don't have to go looking at a graph to find that information, okay? So, number 8, we are going to write an equation in slope-intercept form. So, again, y equals mx plus b. It says a line perpendicular to y equals negative 3x plus 2. What do I do with that information? How? It's dealing with the slope, right? What is the original slope? Where'd you get negative 3 from? It's in the equation, right? It's in the slope spot, so our original slope is negative 3. Are we going to keep that slope, or do we need to change it? Yep, because we want perpendicular. So remember, perpendicular is opposite reciprocal. So what's the reciprocal of 3 over 1? 1/3. Opposite of negative is positive. Okay, so you flip the fraction and change the sign. Okay, and then what is the reason for this coordinate? What does that stand for?
Your coordinates.
That's your x and y coordinates. Yep. So 6, 8. That's our x and y. So just like we did on number 6, now we're going to fill into our equation. What's my y value? 8 equals 1/3 times 6 plus. Why do we not put plus 2? A lot of us put plus 2 from here.
It's perpendicular, so it's going to change your b.
That will change the slope, but the reason we're not going with that b is because this this equation does not necessarily go through this point. Okay, so the reason we find all this information is so we can find a new b. Okay, so I want to clarify, the only thing you get from this equation is the slope. Okay, once you get the slope, you do not care about anything else. Okay. So let's continue solving this. We have 8 equals, what's 1/3 times 6? Yep, because 6 divided by 3 is 2. Then what do we get for our b value? Yep, b equals 6. Don't brain fart here. What's the last thing we have to do?
So put in the equation.
We just have to write the equation. Remember, 2 most important things are the slope and the b. So y equals what?
1/3 x plus 6.
Yes, 1/3 x plus 6. Nice job. Number 9. A lot of you came up to me and said, what the heck is that? Okay? Like I said, biggest thing is going to be reading the directions. Okay? Even when you're reading the problem, it's going to probably give you some context clues as to what that means. Okay? So, if I look at this, it gives us the rule applied to a point, and which part of the coordinate system is the translated point located. So, what that tells us is that this is describing a translation. What's a translation?
Like sliding up and
Right, it's just moving on a graph, going left, right, up, and down. Okay? So, this is the rule. What is that rule describing? What's it saying? Yep.
left to the 1.
Right, this is describing the x, this is describing the y. So, what I always tell people is write your own rule so that you can just plug things in, kind of like writing your own formula. Okay? So x, we said, is subtracting 3, so I got that from here, and y is adding 1. Yep, I just got these 2 numbers from that rule there. Okay, so how do you think I figure out the rule applied to that coordinate?
Minus your x and then plus your y.
Right, we're just going to plug in those values. So our x is 2 minus 3. Our y is -7 plus 1. So what's 2 minus 3? -1. What's -7 plus 1? -6. Okay. So now it wants to know where it's located in the coordinate plane. Okay, so here's my coordinate plane. -1, -6 is down here. Do you agree?
Yes.
Okay. Which quadrant is 1?
Top right.
Top right. It's always going to be 1 because that's where x's and y's are positive. Now, to figure out 2, 3, and 4, what direction do we go? Do we go down or do we go left? Left. Yep. So, what quadrant does our point lie in? 3. Yep. All right, jumping up to number 10. So number 10 here, it's talking about a quadrilateral. What's a quadrilateral? Four-sided shape. So quadrilateral is rotated 90 degrees clockwise to produce A, B, C, D prime. Is each statement true? So we're thinking about a rotation. Here, I want you to understand that whenever it's talking about sides, it's talking about side lengths. Okay, so if it says AB equals AB prime, they're talking about their side lengths, not the specific side. Okay, so is it true that AB is equal to A prime, B prime? Would those lengths of AB stay the same after a rotation? Yes. Yep. After rotation, the lengths are going to stay the same. If AC, what's this mean? This means parallel. If AC is parallel to BD, then AC prime is parallel to BD prime. Yes. Yep. Last one, measure of angle ABC is less than measure of angle A prime, B prime, and C prime. Right. Okay. Understand that with translations, reflections, and rotations, nothing of the figure is changing size. Okay, nothing is changing size. So what should this say if it was true? It should say equals. Okay, I'm going to ask you this. What if I change the rule here to a dilation? Would that change some things? Okay, what's happening with the dilation? It's getting bigger or it's getting smaller. Okay, so would the lengths of AB stay the same? No, okay, because the side lengths are getting bigger or getting smaller. Would the sides still be parallel to each other
Yes.
after dilation? They would still be parallel to each other, okay? Again, length does not have anything to do with whether they're parallel or not, okay? Would the angle measures stay the same?
Yeah.
The angle measures would stay the same, okay? All right, so rotation, reflection, and translation work the same. Dilation is the one that you have to be a little careful with, okay? Any questions on that one? All right. Number 11, it says represent the reflection across the y-axis. Okay, how did you guys attack this one? You remember the rule?
Yeah, like the like minus x and plus y.
Okay. What I think is going to help most of you is drawing a picture instead of thinking about it in your head. Draw yourself that picture. Okay. So I'm just going to pick a random point. I'm going to put it here. Okay. I'm going to pick, is my x negative or positive in that spot? X is negative. What about my y? Is positive. Okay. If it says reflect over the y-axis, here's my y-axis, so this point's going to end up over here, right? Okay, so now what is my x value, positive or negative? Positive. What's my y value? Also positive. So comparing what happened to the x's? They changed signs, right? So it turns into negative x. What happened to the y? Stayed the same, so you keep it as y. Okay. What would a 180-degree rotation rule look like? What happens to the original coordinates?
Both go negative.
They both switch signs, right? Do they switch spots? No, they just switch signs, both of them. Okay, good. So yes, I highly recommend drawing pictures to help you out with these. Okay? All right, number 12. I know it's a little tricky visualizing it. Okay, what I think will help is drawing yourself an x and a y axis. Okay, so here's my x and y axis. Would a rotation of 180 degrees get us from our pre-image to our image? So taking this and turning it 180 degrees, would that map it onto itself?
Yes.
Yes. What is a glide reflection? It slides and flips. Okay, it does both. If I slid this and then flipped it, would that get me to the image?
No.
No, because this would be on the wrong side. Okay? Nope, sorry, wrong. Rotation in 90 degrees. So we're going to bring this about up here. And then a reflection across a vertical line. So then we flip it this way. Would that get us to our image? No. Similar idea. Reflection across a horizontal line, so I could flip it over that x-axis, and then a rotation 90 degrees. Would that get us there?
No.
It would not, because that point would still be on the wrong side. This last one, reflection across the vertical line. So if I reflect over the y-axis, and then I reflect it across a horizontal line, which could be our x-axis. Would that get it mapped onto its image? It actually would. Okay, because if I reflected this, here's my point. That point would end up over here. And then if I reflected it over that x-axis, do you agree that point would end here? Yes, so that's why E is also an option. Okay. Two more. Number 13 says find a pattern for the following sequences. Use the pattern to find the next two terms. Why do you think I'm reading directions all the time? Because that's what I want you to do. Okay, just so you know, when you read the directions, it helps describe the problem that you're looking at. Okay, so how do I figure out a pattern? See how far apart they are, like kind of finding the difference. -4 to -1, what's happening? I'm adding 3. Can I assume all of these are adding 3? No, you have to double check. -1 to 2. Add 3, 2 to 5. 5 to 8. Everyone agree our rule is adding 3. Okay, so what do I need to do to find my next term?
Add
Add 3 to get 11 to get the next term. Add 3 to get 14. Good. B is with a picture. What was the pattern you noticed on the picture?
1 less than and then 2 less than. Or 1 greater than or greater than 1.
Right. How many arrows do we have or less thans do we have in the first one?
1.
1. What about the second one? 2. 1. 2. How many should this one have? 1. This one should have 2. Yep. Number 14 has 3 different parts. Part A, Part B, and Part C. In order to answer Part B and C, you have to answer A first. Okay, so you have to do these in order. You have to answer A before you can answer the rest. So, on Part A, it's asking us which triangle is congruent to PQR. Okay, this is more just looking at the picture. Okay, so this is my main triangle. Is JKL congruent to PQR? No, one of the side lengths is just a little bit longer. What about STU? Nope, it's a little bit bigger. Is DEF congruent?
Yeah.
Yes. I'm going to give you a hint right now. It will never be none. Okay, there will be one so that you can answer Part B and Part C. When you answer Part A, you are only talking about those 2 triangles now. Okay, now I'm comparing PQR and DEF for Part B and Part C. So, looking at Part B, it's just asking which side lengths go together. So, PQ is congruent to what in DEF? DE. QR is congruent to EF. And RP is congruent to DF. Okay. And then last one, Part C, is what transformation can be performed to map PQR onto DFE?
Reflection across the x-axis.
It is a reflection across this x-axis. Good. When you're answering Part C, can it be more than one transformation?
No. Or yes, because
It could. Like, you could rotate and then turn, or you can do a glide reflection. Okay, this one was nice because it was just one transformation happening. But keep in mind, it can be 2. Okay? Yes, ma'am. So, you're asking about this one?
Yeah.
So, here's RP in my picture. The one that is congruent to that one on DEF is FD. So if I performed the reflection on that, I would flip it and RP would turn into FD. Yep. Does that answer your question? Okay. Any other questions over any of Part 1, 1 through 14?